Hello and welcome to CCNA Routing and Switching. My name is Siddharth Tiwari. You can call me Sid. I have a decade of experience in CCNA and CCNP, and I'll be instructor for you this for your course. So let's get started. Um, so these are the topics we are going to cover. What is networking? We are using networks all the time. And what types of communication are there? Have you heard about IP addresses before? And types of networks? Well, we are using networks every day. And the OSI model, maybe you've heard about TCP/IP model. We'll discuss both of them. What are the different devices, networking devices? So they work on devices. And we'll get into, well, we are already into networking. So, and what is the scope of networking? We'll discuss all these pointers today. And let's look at what is networking. Networking is just a collection of devices. So we are all connected in the world today with devices. Perhaps you're using a device to look at this video using a network itself. But this was not the case earlier. If you remember about the floppy disks and the CD-ROMs, that was a painful process and it used to take a lot of time. So networks have made our life very, very easy now. Look at network fundamentals. What are these network fundamentals or types of communication? We'll look at unicast, multicast, and broadcast. Any idea about unicast? The name does suggest something called uni. So uni is basically one-to-one. And multicast and broadcast, that's coming up. So that's an example of unicast. Let's look at this unicast. When you talk to a friend in private, that's a real life example. But in terms of devices, if just two devices are talking with each other, that's unicast. What about multicast? Well, multicast is when there is a single source of transmission and going to multiple devices. So you can think of maybe uh, a person doing a meeting and he's the one speaking, only he's the one speaking and everybody else is listening. That's an example of multicast, just like in the classroom. But what is broadcast then? Broadcast also has the same picture. If you think about it, FM or radio broadcast, and it doesn't say it's just this group of people who'll receive this. It's to all. So that's what's the difference. Multicast is just a group of people or devices, and broadcast is one to all. Now let's look at IP addresses. We all have heard about terms like IP addresses, and if you have not, I'll just tell you right now. An IP address is a logical address, and there are two types of addresses. I like to compare an IP address with a home address and a MAC address. Just like we are present right now, we always have two types of addresses. One where we are living right now and what's your name. So I like to compare MAC with the name and the IP address. And that's an example. So let's look at my PC right now. Well, it is connected via internet access. And let's see, does it have an IP address? Well, let's look at this. It has an IP address 192.168.29.224, and that's another IP address pointing to perhaps my router. And these are IPv6. We don't want to get into them right now, but we will, and they are very complicated, but we'll learn all about them. Also, if you look at this address, this is called the MAC address, and this is a unique address for my laptop in my home. So other devices might be having, and this IP address is going to remain with my device till I'm connected. If my device gets disconnected, maybe someone else will get this IP address. So this IP address is not unique completely. It is unique till you are in the network and nobody else can have it. But once my device leaves and disconnects from the Wi-Fi, somebody else will get that IP. But look at this MAC address. This will never change. And nobody else in my home or my office will get this MAC address because this is unique to my device, and that makes helps keep the authenticity so that no, if this MAC address has this IP, nobody else will get it. So this is like your name. Most probably you're the only one with the same name in the house, and you might have a IP address, so you might have a room number. Um, but in that room, you can have multiple devices, but your name will always remain constant. So just think of this example. IP address is like your address, it keeps changing, but MAC is like your name. You never change your MAC address, so you never change your name. Doesn't matter if you're in US or India or California, anywhere you go to some other country, that's going to be your name. Okay, that's an example of IP address over here. And IP address is a 32-bit address. So we'll talk about that 32-bit in a while. And it is a logical address. So it's just given out on there are some ways in which IP addresses are allocated, and we'll talk about them in a while. Yeah, if you're using internet to view this video or to talk to someone, you have an IP address. It cannot be without an IP address. Let's look at different type of IP addresses. We got the public one and the private one. Remember when we talked about IPv6? Well, it's very closely connected to these public and private and how it came into being, came into existence. So these private addresses, public addresses are, remember, 32-bit long. So the maximum IP addresses you can have is 2 raised to power 32. That gives you something around 4 billion IP addresses. That's not enough. And when the internet was growing something around the 90s, they realized that the addresses are going, the spaces are less. So they came out with concepts like private IP and public IP, and something called NAT as well. We'll learn about NAT later on, network address translation. So this device can have 192. And it does have 192. We just saw that my IP address belongs to class C and it is a private IP. How do I know a private IP? It begins with 192.168. If it began with 192.169, that's not private. So it must be in this range. It must be between 16 and 31 for class B. And class A, it must start with 10. Doesn't matter what the last three octets because that still falls under the range. But if it starts with 11, that's a public IP. Now, private IPs are not routable on the internet. But if you look at my situation over here, if I go over, open a web browser and say, let's say google.com, well, I am able to access the internet. And if I say, let's say, what is my IP? Let's have a look. Well, that's my IPv6 address. We'll talk about that. Oh, it's quite different from what we saw. It's different from 192.168. It's 49, and that's the public IP. That doesn't fall in the range of our private IPs we saw right now. So, how come? Well, I just told you something about NAT, network address translation. And to save IP addresses, these many IP addresses in my home which are falling into this range will all have that public IP and they get converted to public IP. So we'll talk about NAT later on. Just remember, private IPs are never seen on the internet and you can never, they're not routable. If you want to route to the internet, you need a public address. So these are classes. So you just saw that even the private IPs are falling into classes, and these are classes. Class A, B, C. That's the only usable IP addresses for devices. Class D was used for multicast. We talked about multicast, remember? One to many. So multicast always starts with 224. Class E, you'll never see that address. It's reserved for research and development. The only one we'll see is 4 times 255, and that is a global broadcast. So let's look at this classes. Well, these were all ways to save IP addresses. Public IP, private IP, divide them. So they divided them into two parts, and then they came up with something called classes. Just think about it. Why can't we have a single class, 0 to 255? We have all these five classes. Why is that? Because we did something called subnetting later on, and we did subnetting, but before subnetting and making it classless, we had classes. And in this class, what's the difference? Class D we cannot use. We know that it starts with 224 and it is bound for multicast. Class E is always reserved for research and development, and you most probably never see a IP address. The only one you will see is 4 times 255, that is a global broadcast address. So, what's the difference? Well, the difference is quite clear here. You can see that class A, there is something called the network bits and the host bits. So network bits, 8 bits, 16 bits for class B, class C, 24 bits, class A, 8 bits. And let's have a look. This one we already saw that. This is the basically the binary form. So it starts with 0, 1, 0, 1, 1, 0. And when you convert that, you'll get the same range as this. So when you convert 1, 0, that starts with 128. Okay, this map makes it very clear. So in class A, there will be only 8 bits or 1 byte. That makes for network, you have something around 2 raised to power 8. Class B, you can only have 16 bits. So 16,534 addresses, sorry, networks, and 16 bits for IP as well. So it's the same value. Class C, we saw a Class C IP address on my PC right now, and we can see that it is 3 bytes or 24 bits are reserved for the network part. So only 1 byte or 8 bits is reserved for the host part. Yellow parts you can never change and they are not usable. Host is basically what host ID is, the IP addresses your devices get when they are on the network. So let's see the example of class C again. It says 3 bits, sorry, 3 bytes or 24 bits are reserved for the network part. And how do we make sure that those don't change? Well, let's look at our settings again. We need to go back to our settings. Let me just go back here. Let's look at the settings. And this is our settings. We see we have a class C address 192.168.29. See, even for the other device, the 3 octates or 24 bits are same. They are not changing. Only the last part is changing. This is 224 my device, and this is most probably my router. How do I make sure? Well, let me show you something. I say cmd, go to command prompt and say ip config, and you can see. So these are IPv6 addresses. IPv4, this is my address of this PC. And this subnet mask tells me which class it is actually. So 3 octates, 255, 255, and 255. That means 3 octates, you cannot manipulate or change anything into that. And the last octet 0 represents that you can change this value completely. That's my default gateway. So default gateway also has the same subnet mask. So these 3 octates, if you look at this, they're all same. But the last part is changeable. So my IP address is different from the router's IP address, identifiable by the last part. That is, my is 224 and the router is .1. And how do I know that this is class C? Well, 3 parts, 24 bits, 888. 3 parts cannot be changed. They are reserved for the network part. So these are the network parts, 192.168.29. Now I have a question for you. How would we know if it is class A? Well, if you have answered correctly, the subnet mask would be just 1255 and the rest of them would be three zeros. So the 255 would represent the network part. One octet means 8 bits. So we'll have less networks but more hosts. What about class B? Just think about it. Well, the answer is same and similar. Not the same, but similar. We will have two paths for the network. So we cannot change 192.168, but we could change this part. So my PC might have 29 and this default gateway might have 30 and they will still belong to the same network. So class B, 8 bits, that would make it 16 bits reserved for network or 2 octets as we can see here. Class C we just saw. Class A, only 1 octet. So in class A, if I had this subnet mask, my PC could have 192 dot this address and the gateway could be 192.169.30.1 and they'll still be part of the same network because class A, only the first octet would be just as the network part. So this is a little bit about classes and they were developed basically to save those IP addresses. In the end, we came to something called IPv6 and it was invented when we started thinking we'll start running out of IP addresses. So I have the slide running here. Yeah. So that's a basic introduction to CCNA routing and switching. You can continue with this course and we will start with subnetting and other topics like NAT later on. Thank you very much.